Welcome back to our Mechanics of Materials video lecture series. In today's session, we are going to learn about an important structural element, that is fixed beams. This is a continuation of indeterminate beam analysis and plays a crucial role in modern structural design concept. By the end of this video, we will understand about what a fixed beam is, why it is used, and also how fixed end moments and reactions are calculated. Let's begin. Before we move into fixed beams, let's recall a familiar concept, that is cantilever beam. A cantilever beam is a beam which is fixed at one end, free at the other end, which shows maximum deflection at the free end. The problem is due to free end, the deflection is very large and may not be safe in real life structures. So what do engineers do? They provide an additional support at the free end. This leads to a new type of beam known as fixed beam. It, it is a type of beam which reduces deflection and increases stability. In today's video lecture series, we will cover the following topics: the concept of fixed beam, the calculation of fixed end moments, and support reactions. These concepts are very important for solving real life engineering problems. So let's explore. A fixed beam is a beam whose both ends are fixed, which is completely restrained against rotation and translation, which means the beam cannot rotate at supports, the beam cannot move vertically or horizontally. Due to this restriction, the slope at both ends becomes zero and moments develop at supports. The important insight is, unlike simply supported beams where moment is equal to zero at support, fixed beams have moments at the supports. So fixed beams behave differently and are more rigid when compared with simply supported beams. So now let's understand why fixed beams are preferred. The advantages of fixed beams are less deflection because the both ends of the supports are restrained against translation as well as rotation. It provides better stiffness and more resistance to bending. It also provides economical design. Reduced bending leads to smaller sections. It provides higher stability, which is suitable for heavy loads, and it also used in real life structures such as RCC frame structures, building beams, and also permanent construction. So fixed beams are widely used in modern engineering and also which is used for heavy structures where high loading is intended. So now let's discuss the most important concept, that is calculation of fixed end moments. Fixed end moments are the moments developed at the end of the beam when it is fully fixed and subjected to loading conditions. Example, if you consider a beam with uniformly distributed load, what happens there? The beam tries to bend but support resists rotation. So moments develop at both the ends. These moments are called hogging moments or negative bending moments. The fixed end moments depend upon the following factors, that is the type of loading, span length, and boundary conditions. In a fixed beam, reactions are more complex than simple beams. Fixed beams include vertical reactions due to applied loads and end moments due to fixity. There is no rotation at the supports. This is a key condition. The important difference between a simply supported beam and fixed beams are, in simply supported beams only forces come into play, whereas in fixed beams forces as well as moment come into play. This makes fixed beams statically indeterminate. Let's quickly summarize today's learning. We have learnt about the following topics. The fixed beams are restrained at both ends. The slope at supports are zero. Moments develop at supports. Fixed beams reduces deflection and fixed end moments arise due to load and restraint. In short, fixed beams are stronger, stiffer, and more efficient than simply supported beams. So now let's think deeper. Why are bending moments higher near the supports in fixed beams? The hint is supports resist rotation, loads try to bend the beam. Think for a moment and discuss with your friends for the answer. And also, let's check your understanding of today's concept with two simple questions. First one is in a fixed beam, what is zero at the supports? The correct answer is rotation. Second question is fixed end moments developed due to it is developed due to complete restraint against rotation. So for further learning, we shall refer to the following standard textbook, online lecture materials and practice problems. To conclude, fixed beam concept is the base for advanced topic like slope deflection method, moment distribution method. Thank you for watching this video. Like, share and subscribe. See you in the next video lecture series. Have a good day.